Hi, my name is HARISWAR. I'm from BMMH and I will conduct this exchanger. First, open the cold water valve. Then also open the hot water valve. And then we start the machine. And we switch on the pump and this off water temperature controller. After we switch on the device, we set up the hot water temperature to 60. After we set up the device, we wait until the temperature reaches the 60, and after reaching 60, we adjust the water flow rate to 3 and 3 based on the data. After adjusting to 3 flow rate to 3, and we wait for 5 minutes until the temperature is stabilized. After waiting for 5 minutes, we record the data into our table, and then for the next step, we adjust the data to the flow rate for the hot water 3 and the flow rate for the cold water 2. After adjusting to temperature, after decoding data, we adjust the cold flow rate to 2. After recording the data, we adjust the cold flow rate to 2 flow. Okay, and then we wait for 5 minutes until the temperature stabilizes. After wait for 5 minutes, we record the data for the flow rate of hot water 3 and the cold water 2. After recording data, we change the data for the next following is 3 for the hot water and 1 for the cold water, and wait for 5 minutes. After recording for the third test, we proceed to fourth test where the hot water supply are 3 and the cold water supply are 1. Now we adjust it to 0.1 cold water 0.5. And then we wait for 5 minutes for the temperature stabilize, and then we record the data and proceed to the change to counter flow.
Now after 5 minutes, we have to wait until the temperature steady. Now we get our reading for temperature hot 1, 2, 3, and temperature cold 1, 2, 3 for flow rate 3.0. Alright, and now we have to record our temperature for flow rate 2.0 after 5 minutes. And this is what we get for hot temperature, and this is what we get for the cold temperature. Now I have to change the flow rate to 1.0. And wait for another 5 minutes. now for our cold flow rate 1.0. This is our hot temperature, and this is our cold temperature for after 5 minutes for flow rate 1.0. Our final reading, for flow rate 0.5, this is our hot temperature and this is our cold temperature. Set the flow rate to 0.5 for our final reading.
A very good day, sir. My name is HARISHWAR MOHAN from BMMH3553. So today I'm going to explain about parallel and linear experiment results. So the test 1 will be heat flow liter per minute will be 3, then the cold flow liter per minute also 3. So here the TH1, TH2, TH3, TC1, TC2 and the below TC3 will be the recorded temperatures. So TH1 is stated there 52.6, TH2 is recorded 57.5, and delta TH is difference between TH2 and TH1. So the average TH will be the sum of TH2 and TH1 and divided by 2. Same goes to TC1 and TC2. So same formula is used for find delta TC and also average TC. So the heat efficiency of heat NH, here the value negative 20.25, and for test 1. So NC is the efficiency for cold is negative 19, and the density rho H for hot is 1001.8, then rho C for cold is 1001.1, then the specific heat for hot 417 then for specific heat for cold is 4184.83. QE is 61,326.93, then QA is 57,750.65. So CEB is calculated by dividing QA over QE. That's all. Then the upper data is for parallel and the lower data is for linear. So we move to next slide. So discussion number 1. Using the input and output temperature TH1, TH2, TC1, TC2, create a simple profile chart for each flow. For this one is the for parallel flow chart, and both are parallel flow chart. We have did 4 graphs for parallel flow chart and another 4 graphs for counter flow chart. So this one on my left is test 1, on my right is test 2. So on test 1 we've plotted according to the data we recorded. Okay, so this one will be on my left will be test 3, on my right will be test 4. So this one for counter flow chart, on my left will be counter flow chart for test 1, on my right will be counter flow chart for test 2. Then this will be counter flow chart for test 3 on my left, and on my right counter flow chart for test 4. That's all from me, sir.
Assalamualaikum warahmatullahi wabarakatuh. My name is ADIE ZULFIKRI bin MAZLAN from BMMH1/2. Okay, I will present about the discussion number 2, number 3 and conclusion. So based on the information in the result table, create a chart of energy balance coefficient against heat temperature. So this is the energy balance of coefficient for parallel flow and counter flow. This calculation is needed for in the chart given. So energy balance of coefficient will put to the vertical axis, and the heater temperature will put at the horizontal axis. So this is the trend for the parallel flow and counter flow. Number 3, find the LMTD and use this to calculate heat transfer coefficient for each heater temperature. Okay, this is the calculation for the LMTD and heat transfer coefficient. LMTD is for log mean temperature difference. So the formula is TH2 minus TC2 minus TH1 minus TC1 over ln TH2 minus TC2 over TH1 minus TC1. So this calculation for the parallel flow and counter flow. From this, we will use to in the heat transfer coefficient, which means U equal to QE over area times LMTD. So this heat transfer coefficient will give us the comparison between the parallel flow and counter flow. So we get to see the differences between the both flow given. Number 4, compare heat transfer coefficient of the two heat exchanger. So this is the table for parallel flow and counter flow. This is the comparison. We get the comparison from the calculation before. So this is the result. Conclusion: based on the laboratory's activities, we conclude that we are able to show the different cold flow rates effect the performance of the heat exchanger in both parallel and counter flow connection when hot flow rate and heater temperature are fixed. We got analysis the result gained from the parallel flow and counter flow and discuss the reason for different result for both flows. Determine which flows give the best heat transfer rate, which is counter flow is best because the heat transfer coefficient U for counter flow is higher than parallel flow based on the calculation. We are able to operate the TD360A concentric tube heat exchanger when conducting the experiment with proper procedures given by the instructors to get the analysis and collected data of the parallel flow and counter flow experiment. Number 5, we got the comparison of the effectiveness in heat transfer between the parallel flow and counter flow. Last but not least, able to use the log mean temperature difference LMTD formula to calculate the heat transfer coefficient U for the comparison and prove the strengthen the result. So that's all from us. Thank you.